Hello everyone. So this is my third question based on strain energy. So here this is the question. A steel rod 40 mm in diameter is of 2.5 meter long, and here find the maximum stress induced when a pull of 80 kilonewton is applied gradually and suddenly. Also find the maximum elongation. Take E is equal to 105 gigapascal. So here it says that a steel rod 40 mm in diameter. Diameter means it's a circular rod. So the circular rod diameter is of 40 mm, and length is also given here. So this is the length of this rod, and length is L is equal to 2.5 meter. Here it says that find the maximum stress induced when a pull of 80 kilonewton is applied. Here the load condition is pulling is 80 kilonewton is applied gradually and suddenly. So here we have two conditions, that is gradually applied load and suddenly applied load. And here also find the maximum elongation. Maximum elongation means what happened when we apply a load in this steel rod, that then what will happen, this rod will get elongated because of the loading action. So here due to this loading action, so this length we have to find, this length delta L. So it's nothing but the elongation of the steel rod due to this applied load. So here in the question what we need to find is the stress and the elongation for both condition, that is the first is gradually applied load, and second is suddenly applied load. Okay, so now here I'll write the given datas here now, and it was 40 mm and the length of this bar was up to here is 2.5 meter long. So D is given, that is nothing but the diameter of the bar is 40 mm, length is equal to 2.5 meter. If we convert this meter to millimeter, then we have to multiply it with 1000 and it will come around 2500 mm. And load is also given, that is P is 80 is equal to 80 kilonewton, and we have to convert this kilonewton to newton, then 80 into 10 to the power 3 newton. Now here in the question what we need to find is stress and the elongation, that is delta L. Here also E is also given, E is equal to 105 gigapascal is equal to 105 into 10 to the power 3 newton per mm square. So these are the given data. So first solution will solve for a gradually applied load now. Okay, so in case of gradually applied load, so here in case of the gradually applied load, so now maximum stress for, in case of gradually applied load, the maximum stress is denoted by this term, that is sigma is equal to P by A, and this derivation has already been done by us in my previous video, so you can go and check it out. So here see, P is already given, that is nothing but the load, and A is nothing but the cross sectional area of this steel rod. So now see, P is already given, P is nothing but 80 into 10 to the power 3 upon area, that is nothing but pi by 4 into D square is what, D is the diameter is 40 square. Then we'll get the value around 63.66 Newton per mm square. So this is the value for the stress. Now for the gradually load applied, we need to find the elongation also, the maximum elongation. So here we know that the formula for elongation, this is nothing but the change in length is equal to PL upon E. So here see, it's not the P, it's the sigma. Okay, so sigma we have already the value for this sigma, that is 63.66 into the length of the steel rod is 2500 upon E is 105 into 10 to the power 3. So from this we can get the value is around 1.516 mm. Okay, so now it's done for gradually applied load. Now next is to find for the suddenly applied load. So second is to find for suddenly applied load. Suddenly applied load. So here also we need to find for the stress as well as for the change in length, that is the elongation of the steel bar. So for finding for the suddenly applied load, we know that stress is equal to 2P upon A. So this formula has also been done in my previous video, you can go and check it out. So here also we know all the values, that is 2 into P is nothing but what, 80 into 10 to the power 3 upon area is pi by 4 into D square is 40 square. So we'll get the value around 127.32 Newton per mm square. Now here we need to find for the delta L is equal to sigma L by E. So we know the value for this also, that is sigma is 127.32 into L is 2500 upon E is the 105 into 10 to the power 3. So it will come around 3.03 mm. So here you can see that this stress in case of the suddenly applied load is 127.32, and in case of the gradually applied load it's 63.66. So stress in suddenly applied load will be double the stress in gradually applied load. So therefore here the deflection will also be double in case of the suddenly applied load compared to the gradually applied load. See, the elongation is in case of the suddenly applied load is 3.03, whereas in case of the gradually applied load is 1.516. Thank you.